I'm glad that he's here, and he's going to talk about a project called Banana Phone that I know little about, so I'm very curious about that as well. So please, a big round of applause for Matthew. Thanks.
Seems to be. All right. One sec here. Good afternoon, everybody. So I'm here today to talk about Banana Phone. It's a project I've been working on now for about a year with 24/7 Intouch. We're already on our second version, and it's running Janus Gateway now, which has been a really nice improvement. And so I'm just going to talk about where we started and oh, microphone. Thanks. Thank you. And where we're going with it. So just a little fun fact, the name Banana Phone is actually based on a song by a Canadian children's singer named Raffi. So if you ever want to hear why we named it Banana Phone, you can just look that song up. I did have it in the presentation, but the sound wasn't coming through. So 24/7 Intouch is primarily a contact center. We've got about 15,000 employees. We're in 18 campuses worldwide, and we do about 70 million interactions per month. So our channels include voice, chat, email, social media, and at the bottom right, you'll see we've got Lively, which is a new startup that we're working on, which is focused on artificial intelligence, machine learning, and robotic automation. So we're building a really neat stuff there, and what we're doing with Banana Phone, I hope, will eventually tie into that as well. And so here's just a map of where we're located. And we have some ambitions, as you see, to come to Europe as well. So more to come on that as time moves on. I'm a manager of open source telecom at 24/7 Intouch. So it's a new department that we started actually when we started Banana Phone. I've been in telecom for over 15 years, I guess about 17 years now. Most of that I was working at our local phone monopoly in the wireless space, primarily running Ericsson, Nortel, stuff like that. And I'm passionate about open source and innovative technologies, and I'm a Linux and open source enthusiast like many of you here today. And if you want to reach out to me, I've just got my matrix contact information up there to keep spam at bay, so in case this is published, so at mjoubert, matrix.org. So why did we build Banana Phone? I think a common thread with WebRTC is it allows for greater innovation. Obviously, you can do a lot more with WebRTC and a lot easier than some of the old protocols. It's super portable. Like anything that can run a WebRTC stack can pretty much run Banana Phone. Chrome OS, anything that runs Chrome really can run it. So it also has compatibility because of Janus with Firefox and others. There's big cost savings running in an open source ecosystem. That wasn't the driver. The driver was, of course, innovation and portability, but cost is a factor for sure. And we thought we could increase the quality of telephony with using these technologies because they allow us to scale out in a way that we can do it. It allows us to scale in a way we want as opposed to what our vendors want, which is nice. So Banana Phone at its core is comprised of these three technologies. Now there's a lot more to it, but it's WebRTC based, which gives us the TLS security and all of the latest web technologies. It's Janus powered, which I really like because it gives us a client that is actually then agnostic to the backend PBX. Some of the other signaling protocols are proprietary to a specific platform. This isn't, it's pluggable, so I really like that. And Kamailio as our core SIP server, which provides us our registrar, proxy, and our billing. And we use Kamailio as kind of a super node where everything passes through signaling-wise so that we have the ability to track all aspects of every call. What we've got here is a picture of version 1, and really it started with going to SIP.js's website and trying it out with a FreeSWITCH box in our lab. And quite frankly, within minutes, we were able to make calls by connecting it to our existing infrastructure. So the next challenge was well, how do we make this scale? How do we make this bigger? And what I found was that we had to put Kamailio in front of it, not because FreeSWITCH couldn't do it, but just to simplify some of the routing. And the next slide, I'll explain why. And then we've got our SIP.js stack over here, and then for persistence and replication of the data, we've got Postgres with bidirectional replication pictured at the bottom. So they all share the same Postgres database for that. So this is just a little screenshot of the version 1 phone. Very simple, and deliberately so. We started off as simple and controlled because we wanted to see how this would actually work, if it was safe to deploy. We didn't have a lot of experience in this space at 24/7 Intouch, so we didn't want to just throw a product out there that might have a negative impact for our customers. So we did a very controlled experiment, started with 1 or 2 users, and then 10, and then 20, and then it just kept going. It hasn't had any problems and has been working quite well. So in version 1, SIP.js based, it uses Kamailio to query the AOR, which is actually held on FreeSWITCH. And Kamailio then just injects a header to let FreeSWITCH know which context it was in, or realm. And then we loop over any branches that might be found in case the users are registered on multiple computers. So we just branch it out. And then at the very bottom line, we've got FreeSWITCH, which calls Sophia contact. And then we just use the header that Kamailio passed to send the call through to the user. So some lessons from version 1 is that I would say SIP.js was a good performer. If I had one complaint about SIP.js, it would be it's a bit sensitive to hard transport hits. Not packet loss per se, but if there's a reset, it will drop your call. So that was a bit of a nuisance in certain areas where we had problems with our internet connectivity. FreeSWITCH was an excellent performer all around, so wanted to keep going with that. And having it deployed as a Chrome extension is an interesting thing because we did an extension-based deployment for a couple of reasons, but one of them is it's super easy to deploy and everything is nice and self-contained within the extension. But it wasn't ideal because if you want to push a change to your application, Google will make you wait between 2 and 48 hours depending. So very quickly you learn that you gotta have a way of pushing changes out quicker. So all of a sudden you're finding yourself dependent on the web server you were trying to avoid. And the other thing is Google can pull your extension if they don't like something about it, if their policies change, or you happen to step on something that you didn't realize was a policy violation. So there's risk. But otherwise, the quality has been excellent. So with it being a success, we decided that we want to keep going with this and we want to grow it. So we started version 2, but this time as a progressive web app. Progressive web app de-risks the dependency on Play Store because, well, it can be run on a web server, so you don't have to run a separate application to protect your business. It also removes SIP.js from the stack and allowed us to build some really interesting features for call centers. So one of them is extension pooling, and so now with an API call, I can dynamically assign a phone number to one of our agents. What happens in a lot of call centers is you fix your phone numbers to desk positions. And so if you have 2,000 desks, you have 2,000 phone numbers, but you might only have 500 people working. So you got to buy all those extra DIDs. What this allows us to do is copy DHCP's model and just lease them until they're done. We're using them for the day, and then they can be dished out to someone else. Because we've reintroduced a web server, or introduced a web server rather, we can now supply the interface via that server and push out changes rapidly. And it also allows us to customize the phone and the UI based on the profile. And that could be anything from auto answer, different keypads, different aux states, and even if we wanted to, skins. We've also added middleware. So downstream, we can say FreeSWITCH or asterisk. Doesn't really matter anymore because we have that middleware in place. We can provide our telephony applications in an agnostic way. So Banana Phone doesn't care what you're using because of that middleware. And the automations also allowed us to increase our automation and horizontal scale. And we do that using Chef. And then call recovery. Kamailio, sorry, not Kamailio. Janus has a really great call recovery feature, the session reclaim. And that was one of the driving pieces of the decision to go there. Now, this platform is deployed globally, but there's a lot of components, and so I didn't want to draw this crazy network diagram that would have, been too hard to read. So I've opted instead to show you what the environment looks like in this stack. So at the top, we'd be looking at our proxy routing and transcoding layer, and in there we're using Kamailio and RTP engine. So it allows us to route calls efficiently and transcode if we need to. For our centralized storage of data, sorry, let me just back up. I just wanted to touch on two things with Kamailio that I think are important. Anyone considering deploying Kamailio should strongly look at using DMQ and HTable. Those two features are frankly incredible and super high performance. So they are for sure one of the reasons why it works so well. In our persistence and accounting area, we're using Postgres BDR again. It was very solid in version 1, so I wanted to keep that moving forward. InfluxDB, that's a time series database, which is ultimately used for graphing later on with Grafana and alarming in reports. Being an old telco guy, you'd have to expect that there's a Radius platform in here. So FreeRADIUS. I'm a fan of Radius because it is just going to work with everything. So if you run any legacy equipment in your environment, you can just send your Radius request to that platform. And then you can also decouple those database handles from your proxy. So Radius, I think good. Maybe some of you think bad. And then that all feeds into SQL Server, which is our enterprise database. Our telephony applications are right now all using FreeSWITCH. We use it for queuing, a combination of mod call center and mod FIFO, depending on the use case. Conferencing in FreeSWITCH works really well. The IVR functionality, we've been able to build some really exciting telephony applications. FreeSWITCH makes it really easy to build IVRs, especially if you're a Perl developer like myself. I can't seem to shake the habit. But it's got that FS IVRD process, which works really well. And then we're using open source call recording through Oryx, and they also have commercial adapters if you have commercial platforms that have proprietary protocols like DMCC or TSAPI. I put Janus in the abstraction and mediation layer because that's primarily what its role is in this environment. It allows us to be agnostic about our backend, and so does the API layer and our ETL systems. So those work together to make sure that the Banana Phone client is able to not care. It can plug into anything, more or less, and just work. And then over to configuration and server management. I don't think seeing Homer there is a surprise to anyone. It's a really great tool. The Docker images for Homer 7 were super easy to set up, and within 5 minutes, you've got yourself capturing all sorts of really interesting information. Grafana is pictured there as it is what we use for graphing and some synthetic alarms. We do have regular SNMP alarming, of course, but it allows us to alarm weird drops in calls or spikes in calls or registrations. Chef being probably a lot of Ansible fans in the crowd, but we're a Chef shop. It works really well for deploying servers and rapidly scaling. And then Splunk is used as our security and logging solution for centralized collection. So finally, we hit our endpoints, and you'll see here we've got banana phone, conference phones, whatever. Doesn't really matter what kind of phone you want to use. Anything that's SIP compatible will work with this environment. So some lessons from the version 2 phone is that we found that for FreeSWITCH, in order for Postgres and BDR to be happy, the schema didn't have all the right keys in it by default, so we had to add some primary keys to it. We were able to scale really well using Chef, and we did run into some not issues, but some lessons that Google might, being dependent on a marketplace does introduce risk. And so there's a website here, killedbygoogle.com, and it is an interesting list. They've got about 150 platforms, from Hangouts to recruiting services to fusion tables, that have gone away for one reason or another. So while I really think they're putting out great products and services, the message here is simply that if you depend on them solely, you are accepting the risk of that. So we found that moving away from browser-based SIP to Janus, it did increase performance and allowed us greater reliability due to horizontal scale and the ability to reclaim sessions. Now, this might be, for those of you who have used Grafana, this slide might be pretty basic, but this is just an example. These are just some screenshots I've mashed together from various graphs. So we've got some of the stuff Homer collects at the top that you can actually send off to another Influx database if you want. Some ICMP stuff from Denver to Tampa there. Some MOS score calculations and calls and queue on the bottom. So just to give you an idea of what you can do with InfluxDB and Grafana, it's a great way of visualizing your data sets. So some of the key takeaways. The open source software is super capable of providing high performance and highly available telecom systems. The open source ecosystem did have some challenges in terms of learning curve. Some platforms are perhaps a little more tricky than others to learn, but the trade-off and the effort is worth it. So if you're struggling with trying to understand how to configure Kamailio or FreeSWITCH, stick with it. It does pay off. Our workspaces are a lot cleaner now. We don't have big desk phones in everyone's desk. We've got just a USB headset and banana phone. And we're now poised to integrate with some of our other really cool technology we're working on in the machine learning and AI and robotic automation space. So that's my spiel. Any questions?
Thanks, Matthew. A big round of applause for Matthew, please. Are there any questions for Matthew? Also, I'll just add a question myself. So you highlighted how actually the session reclaim feature actually did help you quite a lot. Could you elaborate a bit on how you actually took advantage of the feature, how it helped you in this context?
Certainly. So I think this might be common or at least not uncommon for companies that operate globally. Our internet providers are all over the place in different cities and countries, and the quality of it can vary from provider to provider. We have a lot of protections in our network to fail over, detect those instances, but there are times where we take a hard hit before the systems can react and move the traffic over. And with SIP.js, the transport is tied directly to that TLS connection, and there's no way of reclaiming it. So when that connection drops, the call drops. With Janus, it's able to do the session reclaim and keep that audio going.
Okay, then another big round of applause for Matthew. Thank you. Thank you very much.
Thank you.